Hello everyone, a very warm welcome back to the channel, and today we have another very good and interesting question from the chapter of trigonometry, the question number 10. The question is asking us that if theta 1, theta 2, theta 3 and theta 4 are the roots of the given equation, sine of theta plus alpha is equal to 9 sine 2 theta, where no two of the thetas, theta 1, theta 2, theta 3, theta 4 differ by a multiple of 2 pi, then the general value of theta 1 plus theta 2 plus theta 3 plus theta 4 would be equal to how much? So the maximum time allotted for this question would be 9 minutes, and ideally you should try to do it within 5 minutes. Okay. So give the question a try. You can also pause the video and then return back to have a look at the solution. So I hope you all have tried. Now the correct answer to this question, first of all, would be odd multiple of pi. Okay, 2n plus 1 into pi. Now the thing is that the concepts and formulas used in this question are sine of theta is equal to 2t upon 1 plus t square, and cos theta is equal to 1 minus t square upon 1 plus t square, where t is tan of theta by 2. Sine 2 theta is equal to 2 sine theta cos theta, and tan of theta 1 plus theta 2 plus theta 3 up till theta n is equal to, now in the numerator we have s1 minus s3 plus s5 minus s7 plus like that it will continue. Obviously it will continue up till the point when this index does not exceed n. Okay, because obviously the index cannot exceed n, so it will keep on going up till it is less than or equal to n. Same is the case in the denominator, that this sum will keep on going and continue until the point when until it does not exceed n. Okay, now clearly we are able to observe a few patterns here. Sign alternates, plus minus plus minus plus minus, like that, and here we have only odd indices, and in the denominator we are having even indices, so it's very easy to remember also. And what is the meaning of SR? SR is simply the sum of the terms tan theta 1, tan theta 2 up till tan theta n taken r at a time, that is SR. Okay, so this is a very important formula that we should always remember. Now let us have a look at the solution. So what we have done is, the given equation we have simply expanded. So on expanding, we get sine theta cos alpha plus cos theta into sine alpha, and sine 2 theta I have written as 2 sine theta cos theta. Now what we'll do is, we'll let t is equal to tan of theta by 2, and we'll write sine theta and cos theta in terms of small t, just like we have learned in the formulas. So that way we are getting this given equation becomes completely in terms of t as written here. Okay, because sine theta and cos theta we have written in terms of t. Now on cross multiplication, the equation becomes this, and on rearranging we get this form of the equation. We have simply collected the terms of t power 4, okay, and collected the terms of clubbed the terms of t power 3, okay, so that it simply becomes a polynomial equation in t. So after this form we have got, we should realize that this particular equation had roots theta 1, theta 2, theta 3, theta 4. So since we have substituted t is equal to tan theta by 2, this equation in t will have the roots tan theta 1 by 2, tan theta 2 by 2. Okay, that is very obvious. So that's why its roots are going to be tan theta k by 2, where k can take the values 1, 2, 3 and 4. Now we need to see that tan of theta 1 by 2 plus theta 2 by 2 plus theta 3 by 2 plus theta 4 by 2 would be equal to s1 minus s3. Now obviously plus s5 cannot come, right? Because there are just 4 terms. So maximum index can be 4. So we are not, we have ended this numerator till here only. And of course, minus s6 cannot come because once again, there are 4 terms. So we can't have sum of terms taken 6 at a time. The index cannot be more than 4. So that's why this particular expression we are getting for this, for the tangent of this angle. Now, what are S1 and S3? They are simply, if we talk about SR, it is simply sum of the terms tan theta 1 by 2, tan theta 2 by 2, tan theta 3 by 2, tan theta 4 by 2 taken R at a time. But the thing is, we already have an equation with the roots as those terms, tan theta 1 by 2, tan theta 2 by 2, like that. So we are simply going to be able to use the properties of polynomials here, because since we have an equation with those terms as roots, so from here we can say that S2 will be 0 because coefficient of t square is 0, right? That's why it is 0. What is it? What about S4? It will be, look, minus plus minus plus. So we'll take the constant coefficient with the plus sign. So plus minus sine alpha upon the leading coefficient sine alpha. We are simply using the formula of sum of roots taken r at a time in a polynomial equation. So that gives us -1. Okay, so S2 I have gotten. I have also got S4. Now these values we substitute in this particular formula. So we are going to get tan of sum of thetas upon 2 is equal to S1 minus S3. Now I have put S2 as 0 and I have put S4 as -1. So clearly 1 minus 1 gives us 0 in the denominator and we get this expression as undefined. Now, obviously, if this is undefined, it can only be possible when this entire thing is equal to an odd multiple of pi by 2. 2 and 2 get cancelled, and obviously we get the final answer as sum of thetas is equal to an odd multiple of pi, which is 2n plus 1 into pi. So that's our final answer. And I think this was not very lengthy, but the only thing was the tricky step might have been to think of this particular step. Once you are able to think of it and able to recall this formula, the question is pretty straightforward. So I really hope you all enjoyed the video, and make sure you hit the bell icon to stay tuned for more such awesome content. Subscribe to the channel, like the video, and comment down below what more would you like to see in the future videos. Thank you all for staying back, and I'll see you all in the next one.